Okay, so we're taking a look at the C02 Assignment Vector Addition by Components and taking a look at number 1 first. A plane travels on a heading of 40 degrees north of east for a distance of 300 kilometers. How far north and how far east does the plane travel? Okay, so let's break this apart. So we've got a plane traveling on a heading of 40 degrees north. So I'm going to go ahead and circle that here in red. 40 degrees north, and actually let me back that up, north of east. So 40 degrees north of east. So let's talk about just that really quick. We've got a compass rose with north, east, south, and west. And by convention, and that means that we get to pick. So by convention, we have north be positive because on a compass rose it's up. East is positive because on a compass rose it's to the right. South is negative because it's going down. And west is negative because we're going to the left. So if we're going north of east, so this is our east right here, we're going north of east, so on the north side of east, at 40 degrees, so slightly less than halfway. So if that is 45 degrees right in the middle, then this right here is going to be 40 degrees. Okay, so we have a plane traveling on a heading 40 degrees north of east for a distance of 300 kilometers. Okay, so the total distance of this vector, 40 degrees north of the east, is 300 kilometers. How far north? Okay, so how far north and how far east does the plane travel? So it wants us to break it into the north component and the east component. So how far north has it gone? So its distance to the north. And how far east has it gone? Its distance to the east. Okay. So let's go ahead and plot this on a graph so that we can look at it a little bit more carefully. So I'm going to make my resultant vector, my total distance. I'll just call that dt. So my total distance is going to be 300 kilometers. Okay, 40 degrees north of east. Okay. So that means, let's go ahead and color code this. We'll say the dn is going to be my red vector here. So dn is my red vector, and blue will be my east vector on the graph. Okay. So I've got de for my distance east, got dn for my distance north. My total distance was 300 kilometers. So now how do I break this apart? Well, now that we've got it graphed out, we can see what we've created here is a right triangle. Okay? So we've got a right triangle with an angle of 90 degrees here in the corner, and we've got an angle of 40 degrees over here in the left corner. And so now we just need to determine what our distance north and our distance east are based on that information. So we get to pull out our trig functions. So we've got the sine of theta is equal to the ratio of the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse. And the tangent of theta is equal to the opposite side over the adjacent side. So what we have to do is figure out what side is what. Well, it's always with respect to our angle theta. So our angle theta right here is our 40 degrees. So our opposite side is the side, just like it sounds, that's opposite, so it's all the way across from theta. So our opposite side is dn. So dn is our opposite. Okay. Our adjacent side is the side that's adjacent or next to our theta. So adjacent to theta is our DE. So DE is the adjacent side. And then, of course, the hypotenuse of a right triangle is always the hypotenuse, which is the side that is opposite the right angle. Okay, so our diagonal there is our hypotenuse. Okay, so if we take a look at this, we want to find our opposite side and our adjacent side with respect to our angle theta, which is 40 degrees. So if I know the hypotenuse is 300 kilometers. I can use that information in both sine and cosine, but it doesn't have a place to use it in tangent because tangent is the ratio of the opposite over the adjacent. So I can't use tangent with my given information. Okay, if I'm just using my given information, I have to use the sine function to find my dn. So I'm going to use the sine function to find dn because dn is my opposite side. Okay, and I'm going to use cosine to find dE because I know that my adjacent side is my distance east. Okay, so I'm going to set this up and say that for, first of all, let me get rid of that really quick. Okay. So for my distance north, the sine of 40 degrees is equal to the opposite side, dn, which is what we're looking for, over the hypotenuse, which is 300 kilometers. Okay, so if I rearrange this equation and multiply both sides by 300, okay, my 300s cancel out, and I get 300 times the sine of 40 degrees is equal to my distance north. So now it's just a matter of plugging it into the calculator of 300 times the sine of 40 degrees. The sine of 40 degrees is approximately 0.643. And then if I multiply that by 300, I get approximately 193 kilometers for my distance north. Notice that I used 193 instead of 192.836 or whatever. We have three significant figures for here, 40.0 degrees north of east, and three significant figures for our 300. They underlined the last digit, indicating that all of those numbers are significant. So my final answer should have three significant figures. Okay. So now I'm going to do the same thing with my distance east. So this time we have the cosine of theta, or the cosine of 40 degrees, is equal to the distance east over 300. Okay, reset that up the same way, so multiply both sides by 300. I get 300 times the cosine. So 300 times the cosine of 40 degrees is equal to my distance east. Okay, so in my calculator I find the cosine of 40 degrees is approximately 0.766. Multiply that by 300. And I find that my distance east is approximately 230 kilometers. Okay, so again, to three significant figures, because I actually got on my calculator 229.81333, etc. I got rounded that to 230 with the 0 being a significant figure, so I give it a little underline there. So to put the final answers on here, my distance north is 193 kilometers, and my distance east is 230 kilometers. Now, if I wanted to do a check to make sure that I got a correct answer there, what I can do is I can now take these two components and plug them into the Pythagorean theorem, because we know that we have a right triangle here. The sum of the squares of 193 and 230 must be equal to the square of 300 kilometers. So if you go through and do your a squared plus b squared equals c squared, it should balance out. 193 squared plus 230 squared should give you the same as 300 squared.